Hello and welcome to this lecture. We're going to take a break from polynomial functions. We're probably going to go back into them in a little bit. I want to take a moment to focus more on quadratic equations once more. Specifically, writing equations from graphs of quadratics. Now you can only do this if you know the vertex, if you find the vertex of a graph, if you find the vertex and you have another point. Now I'm going to explain to you why the vertex itself doesn't necessarily give you the equation. Now, let's approximate the vertex. 1, 2, 3. I'm going to say it's at 2. I'm going to make this line for 2 bigger. We'll make it 2, 2, 2 is the vertex. We'll just say vertex is 2, 2. And let's put that vertex and let's put that back in their vertex form, which is you learned in a previous tutorial. Ignore the A there, that's going to become important. That's how you do that. That's how you put it in there. You give it the equation given the transformations of the graph. Now, if you notice, the vertex only is a single point, and a lot of different quadratic equations can be drawn from that point. So we can just go like that. We can go crazy with it. We can even go, if you'd like. So there has to be some kind of constant that is also in tune with the vertex to give us a point, and indeed there is. So I'm actually going to do something. I'm actually just going to drag down this equation one step further, and I'm going to redraw the graph of this equation, and I'm going to give you another point on the graph that's necessary. So 2, 2, just draw a random quadratic, and then this is 1, 2, well, what am I doing? So 2, 2. So if that's the case, then this is 2, then this is 1. 3 is going to be that point right there. So it's going to be 1, 2, 3, 4, 5. Well, this point over here, we're going to call this point A on our graph, is 3, 5. And we're going to put this similar to how when we did y equals mx plus b to figure out the b, we're going to figure out the a in this situation. So what we're going to do now is we're going to put in this value for a, and we're going to put it back into our equation. So it's going to become 5 equals a, which is the equation, which is the variable we're solving for. 3 minus 2 is 1. 1 squared is 1, so it's going to leave 1 there. Plus 2. So this becomes very easy. A plus 2. A becomes 3. So all we have to do now is to note that the equation for our graph, for our parabola, given the vertex, which is 2, 2, v 2, 2, our equation is y equals 3 times x minus 2 squared plus 2. And it might help you guys to note that in textbooks they use this format for the vertex form of an equation, where h and k are just the translations, and then a is just the fact that you're multiplying it by. That's why we use a. They just decided to use a bunch of different variables. And that's writing. Let's just write this over here. What we did, we worked on writing quadratic equations. And I don't know why when I write using this tool, it seems to pause. But the next thing we're going to work with is the imaginary unit I. We're going to write this over here. It's the imaginary unit. It's not a real number, but they use it because it can be used to find solutions and further enhance our set of numbers. So there's reals, and then there's imaginaries. And then the imaginary unit is I. So the imaginary unit follows a fundamental rule, which I'm going to write over here. I squared equals -1. It is the one time where when you take the square root of it, when you take the square of a number, you'll get a negative answer, which will really contradict our understanding of, if you recall, we looked at end behavior, and end behavior depended solely on the result of squaring numbers and so on and so forth. Well, especially squaring numbers when we dealt with simple degrees. But at any rate, we're going to want to move on, and we're going to want to do some equations that involve the imaginary unit. So let's do simple ones to begin. Let's say what happens since I squared equals -1. What happens when I exists? Well, I will just be the square root of -1, because what we did was we take a square root. I want to If this was our parent one, we just square root, that becomes out, that becomes that, and it works because later on when we square it, we get the I number. So that's one. Let's do another slightly harder one. I cubed. Now, I cubed is a little difficult to think about. So what I will do is I'm going to show you guys how to simply solve for I. We're going to use our imaginary unit, which we can convert to, and then we're going to take that out of the I, and then all that's going to be left is I squared times I. Well, I squared is -1. So that becomes -1 times I, or negative I. Let's do something different. Let's do I to the 6th power. Well, let's take out as many I squares as we can. We can take out I to the 4th times I squared. That's an I squared right there. And then we can take out another I squared out of that. So that becomes I squared times I squared times I squared. Which becomes -1 times -1, which is +1, times -1 again, which is also -1. But let's do another one. Let's do I to the 4th. That becomes I squared times I squared. And that's -1 times -1, which is +1. So there's a lot of different answers for I. And what I like to do, as soon as I find an answer for I, is I like to use it on the calculator. So use I on calculator. And using it on a calculator makes you kind of wonder, what is the point of using I and figuring out other methods for solving for I when we can just solve from the calculator? And a lot of professors like to argue that knowing about y helps us when we're trying to solve different equations and so on and so forth. And I'll grant them that it's very important. So what you're going to want to do is you're going to want to use a calculator as a tool to ensure that you have the right answer, not necessarily to solve the problem for you. So in this situation, I'm going to show you exactly how to get I. What we do is we're going to go into our second, which is right below the y squared, and we're going to want the y equals graph. And on the bottom, right in the center, our decimal point, which we use to input decimal numbers, we're going to press that number, and because we have second up, it's going to give us I. And now we're going to hit the caret key, and we're going to put in the value of I that we'd like. So we'll do this one. We'll do I squared, I to the 6th power. So we'll put 6, and then we'll hit enter. And sure enough, it gives us the answer of -1. Now I'm going to slightly complicate these a little bit more for you guys, okay? We're going to do -3i plus 6 times 4i plus 1. And we're going to try to solve this. So let's first put this into a calculator, see what we're supposed to get. So parentheses, -3, second, I, plus 6, parentheses, end parentheses, start parentheses, 4, second, decimal point, plus 1, end parentheses, enter. We should get, at the end, 18 plus 21i. So let's see what we get. Let's just FOIL. We're going to have to do FOIL. And so it means firsts. Firsts are going to be -12i squared. Outsides, -3i times 1 equals -3i. Insides, plus 24i. Lasts, plus 6. Well, right here we have an I squared. And these are common, these are like terms. Well, I squared, the fundamental rule that we saw earlier was that I squared equals -1. So that's going to be -12 times -1. And then we're going to simplify that to become positive 21i plus 6. So then that becomes 12 plus 21i plus 6. And then we just pull it over and it becomes 18 plus 21i. Now we want to give our answer, we want to give our complex number, which is what this is called when you have a real part and an imaginary part, in the form of a plus bi, where a is the real part of the answer, real part, b is the coefficient, which in this case is 21, and then I is, of course, your number. Now, if you notice, that's exactly what the calculator got. So that's a good way of checking to make sure we have the right answer. And now that we have I by itself, if you notice, let's do this again, I squared equals -1, so I to the first power is -1. So whenever we see I, and let's say we have it in a denominator, let's do a problem. 2i 3 over 3 minus 5i. Well, this I is a square, so it's a square root. So that's not given. We have to rationalize the denominator. If you recall that from algebra. So first we're going to put into our calculator again to get an estimate of what we're going to get. So start parentheses 2 second decimal point end parentheses divided start parentheses 3 minus 5 second decimal point end parentheses. We should get some crazy number. Right there is why the calculator is not going to work for when we're doing these. We're going to have to get our answer and then see what happens, because the calculator is going to try to solve things out for us, and it's going to find that it has to put it in best terms, and it's just not going to work out for us. So it's in our best interest to learn how to do these without the calculator, because the calculator is not going to help us. Now, back in algebra, we learned something about something called the conjugate, which basically sets up a situation where the middle term will disappear, which is exactly what we're going to do here. So we're going to have to multiply by the conjugate. So the conjugate of 3 minus 5i is 3 plus 5i over 3 plus 5i. We're multiplying by 1. Now what happens is this becomes 6i plus 10i squared, right? Because that's 2i times 3 is 6i, and then that becomes 10i squared. And then over here, let's see what happens with the FOILing to see why the conjugate works. 3 plus 5i. We're going to get that. It's going to be for FOIL, so FOIL's right, FOIL. First is 9. Outside is plus 15i. Outside is plus 15i. Inside is minus 15i. And then the last is minus. Let me get my eraser, because it's negative 5i. It is the last, so it's negative 5i times 5i, which is negative 25i squared. So these disappear, which makes it become 9 minus 25i squared. Well, I squared is negative 1. I squared is negative 1, so negative 25 times negative 1, which is going to become I plus negative 20. It becomes 9 plus 25, which equals, well, 9 plus 25 is 34. So our bottom is going to actually just become 34. How about that? Look at that. Let's see. Let's put it in our calculator, see what happens there. A calculator can help us that far. So start parentheses 3 minus 5 second decimal point, end parentheses, start parentheses 3 plus 5 second decimal point, end parentheses. And I'm basically just telling you guys what I put in my calculator, my keystrokes. And let's set this equal. And how about that? Even that tells us it's 34. So that's going to give us a common denominator, proper denominator rather. So this is also negative 1. So how about that? This is going to become 6i plus 10 times negative 1 over 34. And let's pull this up. Let's pull this down over here. That's going to be some it's going to become negative 10 plus 6i over 34. Now, a question becomes, is this in lowest terms? Is this simplified? Well, the rule of simplification is if we can take a factor out of each of these terms equally, then we can do it. Otherwise, it can't happen. So we can take a 2 out of all these. I'm pretty sure we can. So negative 5 plus 3i over 17. Now, you can leave it like this, but what we like to do as mathematicians is we like to keep uniformity. A plus bi was our form, right? So let's try to put that in a plus bi. So real part, which is negative 5 over 17ths plus 3 over 17ths I. And that is our answer to this equation. So all that work to rationalize our answer. Hopefully that is not done with in vain, though, because you've learned something from it. I'd hope you've learned something from it at least. So that's basically everything that we have to deal with for right now, because of the I and the writing quadratic equations. There's one more thing that we have to do with I, which I'm going to briefly go over in the next tutorial, the next lecture. However, we've already gotten to 15 minutes here, and I think that's more than enough information to review from. So, goodbye.